Okay, after knowing the concepts of concave mirror and convex mirror, that is the ray diagrams which constitutes where is the object, at what position is the object, and where is the image formed in both concave and convex mirrors. Now we shall move to the mirror formula, very important from the problem's point of view. Now the mirror formula states that, you can see here, 1 by object distance plus 1 by image distance is equal to 1 by focal length. Or you can even say as reciprocal of the object distance plus reciprocal of the image distance is equal to reciprocal of the focal length. Now, you have to be very careful while taking the object and image distance when the sign conventions comes into picture. Why? Because we have studied what are all the sign conventions when you are moving along with the incident light, when you are moving against the incident ray, and what happens to the height of the object when it is placed above the principal axis, height of the object when it is placed below the principal axis. Those sign conventions has to be taken care while solving the problems or with the mirror formula. So the object distance is mentioned as u, the image distance is mentioned as v. So 1 by focal length, that is 1 by f, is equal to 1 by object distance 1 by u plus 1 by image distance 1 by v. Okay, so 1 by f is equal to 1 by u plus 1 by v is the mirror formula. Okay, now this formula can be we can do slight modification to make it easy for the problems to calculate or to multiply or divide the numbers. We shall do some modifications, okay, because that modification becomes helpful in doing the problems. Okay, of course you should not remember the formula 1 by f is equal to 1 by u plus 1 by v. Now take the same formula 1 by f is equal to 1 by u plus 1 by v. Now 1 by f is equal to, now take the LCM for 1 by u plus 1 by v. uv is the LCM. Now here v gets multiplied and here u gets multiplied. So u plus v in the numerator, uv in the denominator. Cross multiply. F into u plus v is equal to 1 into uv is uv, or f is equal to uv divided by u plus v. So I have written product by sum. So what does it mean? In the numerator and the denominator, you have only two quantities. Which are those two quantities? Object distance, image distance. So in the numerator, you have the multiplication sign, that is product. Product of object distance and image distance. In the denominator, you have sum, that is addition sign. That is sum of object distance and image distance. That's why in short I have written focal length is equal to product by sum. Very important when we do the problems. Okay. Now, remember the concept. We know that the focal length is half the radius of curvature, right? The focal length, the distance of the focal length is exactly half the radius of curvature. Now what you have to do, take this main formula, that is 1 by f is equal to 1 by u plus 1 by v. In place of small f, that is focal length, substitute r by 2. So 1 by r by 2 is equal to 1 by u plus 1 by v. So here take the reciprocal, you will get 2 in the numerator and r in the denominator. So you get 2 by r is equal to 1 by u plus 1 by v. Call this as equation 3. Now what is this thing, you can see here equation 1 and equation 3. See, this formula is when focal length, object distance and image distance is given. This formula is when radius of curvature, object distance and image distance is given. So we have to use the appropriate formula seeing the data of the problem. Okay. Now again we shall do some modification just like how we have done for 1 by f is equal to 1 by u plus 1 by v for this equation 3. From 3 take 2 by r is equal to, again take the LCM here, you will get u plus v by uv. Cross multiply. R into u plus v is equal to 2 into uv, or r is equal to 2 times uv divided by u plus v. So what is that? You can see here you have uv by u plus v. Here also uv by u plus v you have, but you have 2 here, just because from this formula r is equal to 2f, right? So what I can write? Radius of curvature is equal to twice the product by sum. I repeat, radius of curvature R is equal to twice the product by sum. That product by sum is nothing but what? UV by U plus V. That is nothing but focal length. Again you are getting back the same formula. F is equal to R by 2, R is equal to 2F. But these forms, that is equation 4 and equation 2. So please remember that, okay? Because for the problems, if you are using this formula, 1 by F is equal to 1 by U plus 1 by V, again while doing the steps, again you have to take the LCM, again multiply, okay? So that is, take the LCM, get the numerator denominator, again at last take the reciprocal. So instead of that, use this formula directly and find the focal length. And if they give the object and image distance, and if they ask you to find out the radius of curvature, use this formula only to find the radius of curvature. So this is about the mirror formula. Thank you. Okay students, after having understood the mirror formula, that is 1 by F is equal to 1 by U plus 1 by V, it's time we move on to the linear magnification produced by concave and convex mirrors. Now, what is the definition of the magnification? See here, small m represents magnification. It is defined as the ratio of height of the image to the height of the object. Height of the image is represented by h2 or h dash. In some textbooks they write h dash. Height of the object as h1 or simply h. So whatever may be. So it is defined as the ratio of height of the image to the height of the object. It is also given by m is equal to h2 by h1. Now what are the important terms or important observations that we can make from this formula is, suppose here, in the LHS you have the magnification factor m. If that has to be greater than 1, if m has to be greater than 1, which means numerator should be greater than denominator. Numerator should be greater than denominator. That's why h2 is greater than h1. Means height of the image should be greater than height of the object, then only m is greater than 1. This is first one. Second one, m is equal to 1, which means what? The value of m should be equal to 1, which means height of the image is equal to the height of the object. Both the heights are equal, then only m is equal to 1. Then third notification, that is m less than 1. When m is less than 1, obviously the denominator should be more. When the denominator should be more, this quantity decreases, which means h2 is less than 1 or h1 is greater than h2. If h2 is less than 1, then the value of m is less than 1. So these are all the three observations that we can make use of the magnification formula. Moving further. Now, we have understood the sign conventions for both concave and convex mirrors. What are those sign conventions? The first point is, if we are moving along with the incident ray, if you are taking the distance along with in the direction of the incident ray, that should be taken as positive. If you are measuring the distance against the incident ray, that should be taken as negative. Then coming to the height of the object, if the object is placed above the principal axis, it is taken as positive. If the image is below the principal axis, then it should be taken as negative. Okay, so depending on those sign conventions, now see here, this m is equal to h2 by h1. Now if m is positive, which means what? This RHS is positive means if the object and image lies above principal axis, right? Object is also above the principal axis, positive, that is h1 positive. Then image is also above the principal axis, then h2 is also positive. When both are positive, m is positive, which means in which mirror you can expect both to be positive? It is obviously virtual and erect. Virtual and erect means in which mirror? Convex mirror, yes. Now the second, m is equal to h2 by h1 is negative. So when can you expect this ratio to be negative? if the object is above principal axis, the object is above the principal axis, which means H1 to be positive, and image is below principal axis. If the image is below principal axis, it is negative. One quantity positive, one quantity negative. So the ratio results in a negative. So that's why M is negative, means magnification is negative. So what type of image you can expect, and which mirror is this? You are having real and inverted image. If the M is negative, means real and inverted. So which type of mirror? Concave mirror. Okay. Now, note the value of M to be either positive or negative is purely decided by height of the image and height of the object above or below the principal axis. As I told you, since M is dependent on the height of the image and height of the object, depending on the sign conventions, depending on the type of the mirror, we are deciding the value of the magnification, that is the value of M to be either positive or negative. Now, we have the formula M is equal to H2 by H1. This magnification can also be found out by using the ratio of other two quantities, that is, it is defined as the ratio of image distance to the object distance, that is minus V by U. Okay. Now here you can ask me, where is this minus sign came? Actually, this minus sign is resultant of this quantity. That means the sign convention or the sign is only with respect to H2 and H1. So when you are equating, obviously you can equate this negative sign to that sign. Why? Because they are mutually equal to each other, right? So M is equal to H2 by H1 or M is equal to V by U. Since this minus factor decides or it is with respect to the height of the image and the height of the object, that sign has shifted to minus V by U, which means to say that it is a ratio of image distance to the object distance. So you have to be very careful. Image distance and object distance has to be taken from pole of the mirror, means from the pole of the mirror you have to measure the distance, not towards the pole of the mirror. This is also important thing that we have learnt in sign conventions. So that's why for concave mirror, U is negative, means object distance is negative for concave mirror, because we are measuring from the pole of the mirror, means against the incident ray. Against the incident ray if you are measuring means negative. So U is negative, V is also negative. Okay. Now, for convex mirror, why? Because for convex mirror, remember, image is to the left side, right? Sorry, object is to the left side, image is to the other side of the mirror, right? Means virtual. So, when the object is towards the left side, which means you are moving against the incident ray. You are moving against the incident ray. That's why U should be negative. Whereas image is formed behind the mirror. Right. So image is formed behind the mirror. You are taking the measurement from the pole in the direction of the incident ray. That's why V is positive. So for convex mirror, object distance is negative, image distance is positive. Understood? So after understanding this, we can move to the problems. Okay, students. Now we will move to the problems. Okay. Now, what are the important formula to be remembered for problems? F is equal to R by 2. 1 by F is equal to 1 by U plus 1 by V. If you modify that, for the problem's sake, I am telling, you have to use F is equal to UV by U plus V, that is product by sum. R is equal to 2 times UV by U plus V, that is twice the product by sum. And you know that F is equal to R by 2 means R is equal to 2F. Now, magnification M is equal to H2 by H1, that is equal to minus V by U. With the proper sign conventions, or they are also called as new Cartesian sign conventions. In few textbooks they have written new Cartesian sign conventions. Both mean the same. Simply if you call sign conventions also, it's okay. So with all those sign conventions, we have to go with the problems. Now first problem. Okay, this is for 1 mark. So just read out the problem. Listen. The radius of curvature of spherical mirror is 20 centimeter. What is its focal length? Very simple problem. they have given the radius of curvature. So radius of curvature is equal to, they have given 20 centimeter. Then you have to find out what is the focal length. Okay. Now what is the focal length? So which formula you have to use? The straight away first formula. So we know that focal length is equal to half the radius of curvature. Therefore focal length is equal to 20 by 2, which is equal to, focal length is equal to 10 centimeter. So what is the conclusion that you can make in this problem? Always focal length is half the radius of curvature, right? So this is first problem. Now moving to the second problem. What is the nature of, this is also 1 mark. What is the nature of the image formed by a concave mirror if the magnification produced by the mirror is +3? So they are asking, they have given the mirror only concave mirror. They are asking what is the nature of the image. By this thing only you can think what should be the nature of the image if the magnification produced by the mirror is +3. So you can have the magnification value m is given here to be a positive value. Now m is given to be positive value and the mirror they have mentioned is concave mirror. What is the nature of the image? Now please think, take this formula m is equal to, we have m is equal to h2 by h1, right? Consider only these two cases. Now m is equal to h2 by h1. Now they are only telling m is equal to +3, means positive value. Now, no need of getting the height of the image or the height of the object. By this only we can find out, tell the nature of the image. How? Now see here. M to be positive means both should be positive, right? M positive ಆಗಬೇಕು ಅಂದ್ರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಇರೋದು ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ಎರಡರದು ಕೂಡ ಪಾಸಿಟಿವ್ ಆಗಬೇಕು. ಇವೆರಡು ಪಾಸಿಟಿವ್ ಆದ್ರೆ ತಾನೇ m ಪಾಸಿಟಿವ್ ಆಗೋದು. Now think, height of the image is also positive, height of the object is also positive, which means both the object and the image lies above the principal axis. So what type of image? Case 6 of the concave mirror. Okay, case 6 of concave mirror. So what is the image? Nature of the image is virtual and erect. It is virtual and erect. So this is the nature of the image. Now students, moving to the third problem, that is for 2 marks. Okay, it's a 2 marks problem. Now see here. An object 2 centimeter high produces a real image 3 centimeter high. So there is an object whose height is 2 centimeter. Object means what? H1. So it is 2 centimeter. Then which produces a real image, it seems. That real image height is also given. That is 3 centimeter. So an object 2 centimeter produces a real image means with the sign conventions you have to take. So when the image is said to be real means what type of mirror it is? Now only you should get the idea. It is concave mirror. So in concave mirror, except the last case, all other cases, that is from case 1 to case 5, object is above the principal axis, image is below the principal axis. So H1 is positive and H2 is negative. Okay, height of the image is -3 centimeter. Remember, with the sign conventions only you have to take. Now when placed at a distance, that object is at a distance of 15 centimeter. Object distance is also from the pole of the mirror against the incident, right? So negative. So U is equal to -15 centimeter. Why negative means? Why? Because you are measuring the distance from the pole. Okay. Now when placed at a distance of 15 centimeter from the concave mirror, as I have mentioned, calculate the position of the image. Position of the image means you have to find out what is this position of the image. Okay, now you can see in the problems, h1 is given, h2 is given, object distance is given. We have to find out the value of the position of the image or distance of the image. So which formula you will use? You can only think. Now the only formula that you can use is the fourth, that is last one, magnification formula. M is equal to h2 by h1 is equal to minus v by u. So use that ratio. So what you have here, h2 by h1 is equal to minus v by u. Now you have h1 is equal to 2 centimeter plus 2, along with the sign you have to take 2 divided by, sorry, h2 is 3, okay, 3 centimeter, that is minus 3, with this sign you have to take, then h1 is 2 centimeter plus 2 is equal to, this negative sign you can remove outside, then within the bracket you have to find out v divided by, what is the object distance? Minus 15. Okay, now after this, so we will get minus 3 by 2, minus 3 by 2 is equal to, so minus into minus, sorry, minus divided by minus plus, so we will get v by 15. Now cross multiply it, so what you will get, 2 times v is equal to minus 15 into 3, or v is equal to minus 15 into 3 divided by 2, or v is equal to minus 45 by 2, 15 3s are 45 divided by 2, or v is equal to, what you will get, minus 2 1s are 2 2s are 4, then 2 2s are 4, 2 5s are 10, you will get minus 22.5 centimeter. Now this is the position of the image, means object is at minus 15 centimeter, beyond that you are getting the image, that is minus 22.5 centimeter. What does it is negative sign now indicates that? It indicates that we are measuring the distance against the incident ray from the pole of the mirror. So image distance or position of the image is minus 22.5 centimeter. Okay students, next is the fourth problem. Now this is again for 2 marks. An object is placed at a distance of 10 centimeter from convex mirror. Now they have only mentioned convex mirror. You can get the idea of what is the nature of the image in convex mirror. There are only 2 cases. Now an object is placed at a distance of 10 centimeter, which means the object distance. Remember, in convex mirror, object is towards the left side and image is behind the mirror towards the right side. So object distance is negative. Why? Because it is against the incident ray. So u is equal to, object distance is equal to, at a distance of 10 centimeter minus 10 centimeter. Convex mirror of focal length. They have given focal length also. Now see here students, focal length you are measuring in the convex mirror to the right side. Why? Because focal length and center of curvature, radius of curvature will come far behind the mirror, which means in towards the incident ray. You are traveling or you are taking the distance from the pole of the mirror in the direction of the incident ray. So it should be positive, right? So f is equal to plus 15. They have given 15 centimeter. Find the position and nature of the image. You have to find the position of the image and nature of the image. Nature of the image. Nature of the image you only know. Why? Because in convex mirror it is virtual and erect. Okay. Now we have to find the position of the image. Now we have given the focal length. You have given u, but you have to find v. Which formula you will use? Straight away use this formula. Or you can even use this main formula, mirror formula, 1 by f is equal to 1 by u plus 1 by v. Or we have modified it, you know that f is equal to product by sum. You can take that formula and find out the value of v. So you take that f is equal to u into v divided by u plus v. F value is given how much? 15 plus 50 is equal to u value is minus 10. Minus 10 into v divided by u plus v minus 10 plus v. Now cross multiply it. Okay. So upon cross multiplication, what you get? 15 into minus 10 plus v is equal to minus 10. Or 15 tens are 150. Plus into minus, minus 150. Plus into plus, plus 15v is equal to minus 10. Okay. So, minus 10v. Minus 10v. Now what you have to do? Bring this minus 10v to this side. Then take this 150 to that side. Okay. So, yes. So, minus 150 plus 15v is equal to minus 10. So, what you have to get? So, you will get 15v plus 15v plus 10v is equal to, so you will get plus 150. Okay. Now, 15 plus 10 is what? 25v is equal to 150. Or v is equal to 150 by 25. So you can even simplify in the simple only in the 5s are, then 5 1s are 5, 5 6 are 30. So you are getting how much? V is equal to plus 6 centimeter. V is equal to plus 6 centimeter. So this is the image distance. Now see here, object distance is negative, means object is towards the left side. Position of the image or the image distance, you are getting positive value, means towards the right side. When the object to the left side and image to the right side means to far behind the mirror. What is that far behind the mirror? Convex mirror. So what is the nature of the image? Image is virtual and erect. Understood? So now students, moving to the fifth problem. Just carefully listen. An object 2 centimeter high is placed at a distance of 16 centimeter from a concave mirror which produces a real image 3 centimeter high. First one, find the position of the image. Second one, what is the focal length of the mirror? Now carefully listen. An object 2 centimeter high. An object 2 centimeter high and it is a concave mirror. So H1 is equal to plus 2 centimeter. Why? Because height of the object is above the principal axis. So sign convention is positive. So this object is placed at a distance of 16 centimeter, which means U is given, it should be taken minus, right? 16 centimeter from a concave mirror which produces a real image of height. So that real image height is given H2. Since it is below, you have to take it as negative. So minus 3 centimeter. So you have to find out the position of the image and you have to find out what is the focal length of the mirror. Okay. Now given data is H1, U and H2. When you get H1 and H2 and you are given U and you have to find out V, you have to go with the magnification formula, right? That is the magnification, the relationship. So you have to take, therefore, H2 by H1 is equal to minus V by U. Now what is H2? Minus 3 centimeter divided by what is H1? Plus 2 centimeter is equal to, you don't know the V, take right within the brackets. You have to find out V divided by U is given, that is minus 16. Now minus 3 plus divided by plus 2 means minus 3 by 2 is equal to, so minus divided by minus is plus V by 16. Cross multiply. So you will get 2 into V, 2V is equal to, so minus 16 into 3 or V is equal to minus 16 into 3 by 2, which is equal to 2 ones are 2 8s are 16. So minus into plus minus, V is equal to 8 3s are minus 24 centimeter. So you are getting V is equal to minus 24 centimeter. So this is the position of the image, that is V is equal to minus 24 centimeter. Obviously the mirror, that is the image that you are getting is real and inverted. Why? Because they have mentioned concave mirror. Now you have to find out what is the focal length. So you have given U and V. When you know U and V, you can easily find out focal length. Therefore, which formula you have to use? This product by sum. Therefore, F is equal to U into V by U plus V. Okay. Now, F is equal to, what is U? Minus 16 into, what is V? Minus 24 divided by, what is U plus V? What is U? Minus 16 plus, what is V? Plus of minus 24. So, you will get F is equal to minus 16. So minus into minus is plus, 16 into 24 divided by minus 16 plus minus 24. So you get minus 16 minus 24. So what do you get? Minus 16 minus 24. So what do you get? Minus 40. So F is equal to 16 into 24 by minus 40. So what it will go? 8 3s are, then 8 5s are, right? Then you will get F is equal to, I'll shift this minus sign to the numerator, minus 16 3s are 48 divided by 5. Okay, now simplify. 5 1s are, 5 9s are 45, right? So what you will get? 5 9s are 45, then point, then 5 6 are 30. So we will get focal length is equal to minus 9.6 centimeter. Right? 5 9s are 45, 48 minus 45 is 3, then add 0, 30, 5 6 are 39.6 centimeter. So what is this negative sign? Indicates that we are taking measurement from the pole of the mirror. So what type of mirror is this? Concave mirror. What is the nature of the image? Real and inverted. Thank you. Okay students, moving to the next problem, that is sixth problem. This is for 5 marks problem. Find the size, nature and position of the image formed when the object of size 1 centimeter is placed at a distance of 15 centimeter from concave mirror, they have mentioned, of focal length 10 centimeter. Now, you have to find the size of the image formed. So, the size of the image formed means H2 you have to find out. Then, position of the image means V you have to calculate. Then you have to find out nature of the image. Nature of the image. Okay. When the object of size 1 centimeter, object of size 1 means H1 is equal to, object will be above the principal axis. So plus 1 centimeter is placed at a distance of 15 centimeter, means U is given, that is minus 15 centimeter. From the concave mirror of focal length, that is F, focal length is given minus 10. You know why we are taking minus sign? Why? Because we are considering the concave mirror and also the measurements has to be against the incident ray, that is from the pole of the mirror. So that's why negative. Now we have to find out, as I told you, H2, V, then H2 and V. So with the given data, you have object distance, you have focal length, you can easily find out the image distance or position of the image. Use the mirror formula, that is the product by sum. Okay, that modification, that modified formula we use because we get the simplifications very easily, right? So F is equal to U into V by U plus V. So you have F is equal to minus 10 is equal to, what is U minus 15, you don't know what is V, find out. Then you have U again, minus 15 plus V. Then cross multiply it, minus 10 into minus 15 plus V is equal to minus 15. Then multiply 10 into 15, 150, minus into minus plus 150, minus into plus minus 10V is equal to, so this is minus 15V. Okay, now bring this 15V to the left hand side, move this 150 to the right hand side. So what you will get now? Minus 10V then plus 15V is equal to, what you will get? Minus 150. So 15V minus 10V is 5V is equal to minus 150, or V is equal to minus 150 by 5. 5 ones are 5 threes are 15. So we will get minus 30 centimeter. So what does it indicate? The negative value that you are measuring from the pole of the mirror against the ray of incidence or incident ray, right? So the image distance or the position of the image is minus 30 centimeter. Not only that, you have to find out what? Nature of the image. So what is the nature of the image? Since they have only mentioned concave mirror, nature of the image is real and inverted. So nature of the image is real and inverted. Next, moving further, you have to find out H2. You have V and U. So you can and also you know H1. You can easily find out H2 by using magnification formula. That is H2 by H1 is equal to minus V by U. So what is H2 here? You have to find out H2. Then what is H1? That is plus 1 centimeter is equal to minus of V, that is minus 30 divided by U. U is how much? Minus 15. H2 by plus 1 means H2 by 1 means H2. H2 is equal to, now see here, minus divided by minus is plus. So 15 ones are 15 twos are. So minus divided by minus is plus. Outside it is minus. So you get minus 2 centimeter. So height of the image is minus 2 centimeter. This negative sign indicates that the height of the image is formed below the principal axis. Object is above the principal axis, image is below the principal axis. This also gives the indication that it is a concave mirror and the image formed is real and inverted. So this is for 5 marks problem. Okay, very important. Thank you.